Have you ever wondered if anything in the universe can actually move close to the speed of light? We all know light is super fast, about 300 million meters every single second. That's like going around the Earth more than 7 times in just 1 second. But is there anything else out there that even comes close? The short answer is yes, but the full story is way cooler than you think. In fact, there are tiny particles in space that make our fastest rockets look like snails. Take protons, for example. These are the little charged particles inside atoms. In nature, we see protons blasted through space by cosmic rays, and they can move incredibly close to light speed. We even make them go that fast in labs, like in the Large Hadron Collider. There, protons can reach about 99.9999% of the speed of light. If you sent one toward our nearest star, Alpha Centauri, it would arrive just a second later than a beam of light over a distance of 4.2 light-years. That's mind-blowing. Another champion in the speed game is the neutrino. These are ghost-like particles that barely interact with matter. They can travel through an entire planet without even noticing it's there. Neutrinos from exploding stars, called supernovae, have been measured moving at 99.99978% the speed of light. The only reason they sometimes arrive on Earth before the light from the explosion is because light has to fight its way out of the star, bouncing around inside it, while neutrinos just go straight through like it's nothing. And then there's one of the wildest things ever detected, the oh my god particle. That's what scientists actually called it, because it was so unbelievably fast. It was a proton from space that slammed into Earth's atmosphere in 1991. If a beam of light and this particle started a race across a light year, the particle would finish only about 1 yoctosecond behind. That's so close that you could run the race 1 trillion times and barely see a difference. Not everything fast is microscopic though. Some huge objects can spin or move at a significant fraction of light speed. There's a neutron star, for example, a super dense star left over from a supernova that spins so fast its surface is moving at about 24% of light speed. That's insane when you think about how massive it is. We've also spotted stars whipping around black holes at 8% the speed of light. And quasars, those super bright, energetic regions powered by black holes, can spin at about half the speed of light. Even our technology has gotten a tiny taste of high-speed travel. The Parker Solar Probe, one of the fastest spacecraft ever built, can hit speeds of around 0.06% of the speed of light. That's nothing compared to cosmic particles, but for something built by humans, it's impressive. You might be wondering, if we can get that close, why can't we just reach light speed? Well, the problem is that the closer you get, the more energy you need. And that energy requirement doesn't just grow, it skyrockets. You'd need infinite energy to push anything with mass to the speed of light. That's why light itself, made of massless photons, can hit that top speed. But anything with even the tiniest mass can only get close. And here's another mind-bender. What's fast depends on your point of view. In physics, speed is always relative. From the right perspective, you are already moving close to light speed. For example, relative to certain galaxies near the edge of the observable universe, we're zipping away at near light speed just because of how space itself is expanding. The amazing thing is that these speeds aren't just numbers on a chart. They shape how the universe works, how stars explode, and even how we detect distant events across space. And maybe the coolest part, every single second, particles moving at a hair's width below light speed are passing through you. Billions of them, and you don't feel a thing. That's the kind of hidden high-speed magic that makes the universe such a wild place to live in.